I wanted to make a simple solar electric pump to move dirty water out of my way during a construction project. I didn't want to use any electronics or sophisticated components. The pump must run 24 hours around the clock on demand and automatically without requiring any user intervention. And I need to make use of what I have and keep the cost down. For those of you interested in knowing, I'm still settling into my new homestead and recovering from several months of moving work starting in January of 2025. I've already started working on some solar projects and decided to make a video about this one. I find my new property to be stunning. It's huge, it's quiet, and there's plenty of natural beauty to be found even without doing any improvements to the land. I moved here in a bid to save my health. It cost me everything, but I hope it pays off in the end. Hi folks, Dave here. So I'm out at my new property and I've been very busy moving, and I'm currently working on a gray water system, but had a bit of an emergency. You can see I've put in a drain line here. I built a simple little solar pump, which has been working so very well, it's amazing. This is a 20-watt solar panel. This tiny little solar panel also boiled an egg and boiled water in some of my previous experiments. I'll link those in the description. And it's charging a lithium iron phosphate battery. So what about a charge controller? Do I need a charge controller to charge this battery? I like to challenge myself to do more with less. What if the grid was down and I didn't have the ability to do any of this stuff? What if all I had was a battery and a solar panel? Well, you can connect a solar panel straight to a battery and it will charge. The problem is at night, the battery will warm up the solar panel and you'll waste power. So what if I just took a simple diode and stuck that on the battery? Then what? Well, then you have to be careful what size of a solar panel you use. But here I have a 50 amp hour battery and I have a 20-watt solar panel and I have a pump that's using about 50 watts every time it turns on. And it does turn on quite a lot. So there's your charge controller. It's in the sizing of your system. So in a grid down scenario where you don't really have a lot of technology and you got to work with what you have, sizing the system properly and then monitoring it, keeping an eye on it, that's your charge control. And this is going to be for a few months that I'm going to run this system. So I could not make a charging circuit, so I just literally clipped the solar panel onto the battery. But I know what some of you are thinking. That's not sophisticated enough. I've heard that diode strings can be used as a rudimentary and simple charge controller in an emergency, but I never had a chance to try it out, so that's what I'm going to do here. I'm using ordinary silicon rectifier diodes. There's nothing unusual about them. They're just diodes. They're used for rectification of AC voltage and many other purposes as well. It's just the most basic kind of diodes you can buy, the most common. It doesn't matter. You can get them off of motherboards, old circuit boards, out of old industrial equipment, you name it. They're extremely cheap and easy to get, and you can go to any junkyard and get piles of them if you know where to look. Now let's dive in a little bit deeper. So I have a small battery here, and it's important to understand that this is a bench power supply, so it isn't going to behave exactly like a solar panel. But I can get close enough to get a working prototype, and then I can take that out in the field and test it for real. So what I did is I added a Schottky diode here, and I added that in series with all the silicon rectifier diodes, and there's no battery connected. If we look over here, I have a multimeter, and that's measuring the output of my charging circuit after the blocking diode. It's important to include the blocking diode because this is no different than any other charge controller. You want to make sure the power only flows one way into the battery. Here's the negative of the battery. It's all connected, and here's the positive. Nothing is connected. So here's the charging output. So I would just connect that here. And let's take a look at the multimeter when I connect the charging output. Immediately it drops to about 13.07 volts. And the reason for that is this battery is actually not full. So its voltage is more like 13.07 volts. If I take the battery off, the open circuit voltage of the charge circuit is about 13.15. Now granted, I can change that voltage. It's not a static thing. So it's a bit fiddly, but you can see that I have no microcontrollers, I have no inductors, I have nothing sophisticated here. It's just a bunch of diodes that are hooked up to a power source. I did use a Schottky diode, admittedly. Those may not be as common, but they can still be found. And I did that to fine-tune the voltage. This is an example of using what you have to get by. Okay, I went ahead and I added a second Schottky diode in the circuit, and now it's a lot better. It's more like what I'm looking for. I'm getting 13.4 volts open circuit. Of course, when I connect the deeply discharged battery, it will pull the voltage of the battery charging circuit down, but that's exactly what I want. There is some more fine-tuning to do, but I have the circuit working the way I want. I think it's really neat, and I'm shocked how diodes can be used in this way. It's better than babysitting the system and worrying about overcharging the battery. In some of my other research, I found that diodes can make an effective solar electric heating element for cooking food, space heating, and even solar hot water. Check out my diode-related playlists and links in the description to see more of that work. So why am I doing this gray water system? Because of the really poor soils we have in this area, it's basically like clay and it doesn't want to drain water. I wanted to unload my septic tank system by taking the dishwater, so the dishwasher and the kitchen sink, and running that out of a drain line and basically trying to clean that water and use it for other purposes, such as irrigating a greenhouse. But things don't always go like you plan. And in the process, I knew that the 4-inch drain line would simply fill up with water. You have to have somewhere for that water to drain, and I didn't have anywhere. So what I'm going to be doing is a mulch pit design. A mulch pit is basically a hole in the ground. You fill it with mulch, and I will then be collecting that water in a 55-gallon drum. Anyway, I did find a little bit of energy, and over a period of 2 days I dug a small hole in the ground, and I began using that to experiment with different ideas that I have for gray water treatment. So I bought a cheap marine bilge pump. So you do have to be careful with it. It really isn't suitable for draining this type of water, but I figure for $40 I should learn quite a bit. I can work with my own hands, learn about pumps, learn about gray water treatment, and just see what happens. Most of the time I learn by doing and making mistakes, so that's what I'm doing here. I had to get pieces of 4x6 to weigh that bucket down because it's not staying down in the water. So I'll just put these on top and see if that helps. All right, here's one of the first tests. That water has a lot of sand and clay in it, and I'm quite sure that over time the pump will be destroyed, and I can't actually use it that much yet, but this will do for now. And let's turn this on and see what happens. I'm using the float switch right now. So let's hook up the negative side, and the float switch should turn it on. So it's going to cycle on and off because the holes in the bucket aren't big enough. Now I'm still moving, I can't find anything. So I found this old rusty drill bit laying around. It looks like it's snapped off maybe. Anyway, my trusty Bosch drill here. And I got to see if I can make those holes a little bigger. All right, let's give it a try. Yeah, that's what I figured was going to happen. You don't know if you don't try. I hate to drill holes in a brand new bucket like this. Yeah. Thankfully the weather has been cooler. It was like almost 100 almost every day. Now we're in the 80s and it feels like ordinary summer. I'm really ill prepared here for this experiment, but all right, let's do a test run. Brown and white is automatic. Yeah. It moves a lot of water, which is great. This chimp really, I'm gonna take the whole thing out of the bucket. Yeah, I'm gonna have to work on that bucket. It's a good idea, it works. It turned itself off. So it looks like there's a couple inches of water left. That's fine. Yeah, pretty neat. I like this. I'm gonna need to think through this a little harder. I think bigger holes would be necessary. Then I'm gonna use a filter of some kind, and the filter is necessary. I think it's okay to do this for a short time. It removed about 20-25 gallons really quick. Of course, the water needs to be pumped farther away from here, and I'm going to create a leach field, and maybe it's possible to do it without the battery. I am thinking through that. I may actually go with just a solar panel. We'll see how it goes. When the dishwasher and sink are running, this is going to fill up pretty quick, and then that water is going to be taken into a pit, and it's going to sit there, and it's going to be bioactivity, which is going to clean the water. Okay, so here's the latest iteration of the system. I got this green box right here, and that came just yesterday, but the system has been running for several days now. This box will sort of shed water because the top is sealed off, and any water will just come off here and run straight down. And it's working like a champ. We've had probably a few hundred gallons of gray water coming through here. The charging circuit is just a simple diode right now. It's getting a little bit warm, but not bad. And I have a voltmeter temporarily clipped on, 13.3 volts. So I need to keep working on this and make it better. I'm going to be using this system long term. I'm going to keep it and use it for other purposes even after the gray water system is complete. Pretty sure this is going to be part of the setup. And anyway, having a mobile pump that's solar powered is super handy, especially the low cost that I built this system with. Well, I've been out digging again, and I got my mower stuck in the mud. Anyway, I could not get a backhoe. I did, however, get a riser put in on this drain line. So that's going to be very handy if it ever gets clogged. I hope not. But if it does get clogged, this here will help me do the clean out. Done some work on the drain area. And to be honest, I can't quite figure out how I want to build this system. And it's a good thing that the backhoe hasn't arrived yet. So I've cleared out this land here. And I've elongated this trench here that I started earlier, and I've started to fan out over there. I've cleared an area over there, and I believe the first pit will be right about there. I'm kind of experimenting. This is the experimenter, the scientist in me. I just like to see water. I like to see pumps. I like to see what happens when water runs downhill, I guess, because I'm a curious sort of person. It can be just as simple as letting it trickle out onto the ground. I'm well aware of that. In fact, I've experimented with that right in this area here. You can see how I just pumped the water up on this plane here, and it rolled right down the hill. That's gray water disposal for you. You can't do that with sewage, but you can do it with gray water. And as far as the solar part of it, this is working so well. I can't believe how simple this is and how well it works. Here I added a voltmeter. A little bit spendy, but I kind of like it. I need a bus terminal strip to do all my connections. I'm going to push myself to downsize to a 10-watt solar panel. I believe I can pull this off with a 10-watt solar panel. And this little pump system I'm building is going to be fantastic. I have a lot of ideas for this. It's not just for the gray water system. What I want is a mobile, portable solar pump, and it's going to be really useful, especially for greenhouses and those sorts of things. So this system is an interesting experiment, but it's also very serious because I need to get rid of the gray water. But in the meantime, I can experiment with my pumps and digging trenches and watching the water flow. That's always gotten me interested. I love ponds, any kind of flowing water, anything water related I really love. Sounds like something is draining. It's probably the washing machine. I don't know if you can hear that, but it's coming down the pipe. Hopefully I don't drop my camera in that dirty water. So what interested me is the quantity of water coming out of the system is more than I expected. I'm sure I can get quite a lot of water if I can just clean it. It would be great to use that for irrigation purposes. The completion and the conclusion of this is going to be in part 2. If I can ever get this completely finished and working the way I want. I'll also need a load of mulch. And of course the wildlife love my project here. You can see there's some kind of frog just sitting there. I don't think he wants anything to do with me. Let's see if I can zoom in on him. I don't know what kind of frog that is. Big dumb human. I think he just wants me to go away, so I'm going to do him a favor and go away. There's going to be tons of projects. This is just one of them. Hope you guys enjoy the video, and thanks for watching. If you liked this video and you want to support my work, please thumbs up, comment, and subscribe. Thanks for watching, folks, and I'll see you next time.